Thanks for having me here. Just before we even get started, how many over here have heard of NIM? Cool. And what about language called as Crystal? Programming language called as Crystal. And is anybody over here like a hardcore C developer? Okay. I need to be a little bit careful now. Cool. Welcome. So my name is Abhishek. I am a software engineer at Netflix. I'm working on the machine learning infrastructure at Netflix. So I'm a Python developer. I write Python every single day of my life for last a decade or so. And I'm based out in San Francisco. And if you have to reach me, Twitter and GitHub are the best places to learn more about what I'm doing and what I'm thinking. So the way I'm doing this presentation, we'll start with like a quick introduction, very high level, light introduction of what NIM is, because I'm pretty sure almost everybody over here is very new to NIM. Then we will go a little bit in comparison mode. I want to make sure that we look at NIM from Python perspective, because we are Python developers and we want to get value out of this talk. So I want to make sure that I clearly let you guys know why am I doing this talk. Then we'll go into why you should use NIM. I mean, programming languages are hard, right? I mean, you just don't want to invest time learning a new thing if it's not of any practical value. So we'll learn into why NIM is a good tool to have in any developer's arsenal. Then I will go into details of like how you can get started with NIM project. I can showcase some of the actual examples that people are doing with NIM. And then I have lots of resources to share so you can learn more about NIM whenever you get time. Does it sound good? Cool. So what is NIM? So NIM is an incredibly fast systems and application programming language that is expressive, it's extensible, and it's really fun to use. As you can see, it's very much like Python. You can just express what you want in the most minimal possible way that you can do. So who develops NIM? If you have seen the trend that's happening in the programming world, most of the new languages that are being developed are developed by big corporations with a lot of resources and money. So it's really refreshing to see that programming languages are still built now in this day and age by really passionate, super talented developers without any big corporation backing. So like Python, NIM is entirely built by developers who are spread across different parts of the world. And there are over 300 committers who are constantly improving the language, fixing the bugs, and making it a real joy to work with. So NIM is not a new language. It's been around for a long time. And just from the commits, you can see there has been over 12,000 commits made to this language. Over 2,000 pull requests have been merged. 3,000 plus issues have been fixed, and as we speak, there is constantly new improvements and bug fixes that are going into the repo. There are 500 and plus packages, and this is where you will see some differences between Python and NIM. And it's actively been developed since 2008. So this is not something that is like flavor of the month or what's the hype going on currently. People have been using this and quietly building this amazing tool for a long time. And NIM finally is a free software. It's licensed under MIT. So it's very permissible. You can fork it, tweak it, do whatever you want with this. It's really cool. As with any language, a language starts with a goal in mind, like why do you want to create a new language when there are so many existing languages? And the cost of switching to a new language is extremely high. So when you are developing a new language, you better have some really, really strong ambition strong desire and a real problem that you want to solve with the language. So with C, it has a very ambitious goal. It wants to be as fast as C. It wants to be as expressive as Python, and it wants to be as flexible and as extensible like Lisp. And these are really, really hard things to balance. I mean, I don't know if there is any language right out there that perfectly balances all the three things. Like, if you look at newer languages, they either are as fast as C, but not as easy to learn as Python, and they could be as expressive as Python, but they are extremely slow. So this is what really attracted me toward this language. Is like, I love Python. It's the best expressive tool out there, but there are occasions where we want to we hit the limit of Python when it comes to performance and speed, and then that's why there is tools like NIM that can overcome some of the drawbacks. Before we get started, let's just, at a very high level, compare the language differences. First of all, Python, as we all know, is an interpreted language. We have an interpreter, you feed Python code, convert it into a byte code, and then you start executing the code there and there. Whereas NIM is a compiled language. So NIM is a statically typed language. The first step in NIM is like NIM's compiler takes NIM code and converts it into C code. And then it feeds the C code to the standard C toolchain and produces a compiled machine-dependent binary which you can run. So the memory management, as we all know, in Python, we never have to worry about freeing the resources when we consume. With NIM, you have two modes. Either you can have a garbage collector so that you don't have to worry about memory management, or you can go manual memory management. So if you are coming from C++, if you're a game developer, you want that performance, and you can do it by just disabling the garbage collector altogether. It's dynamically typed. Python is dynamically typed. NIM is a statically typed. So each time you create a variable, you have to give it a little bit more thought on like how is the memory structure and what kind of type that you are dealing with. We all know Python has duck typing, whereas NIM actually has generics. So the reason why I'm saying this is, in Python, we can write reusable functions as long as the object that we pass into a function has all the right methods on it. That's what duck typing is. Whereas in NIM, you need to be really careful. Like if you pass person object, it better be of type person, or else the compiler is going to complain. Python is very object-oriented, as we all know. Everything in Python is an object. Whereas NIM is very minimal object-oriented. It does provide you with all the necessary tools like polymorphism, inheritance, all kinds of things that you need to make your code a little bit more robust, but it does it in a very interesting way. It has closure support. The one thing that you don't have in Python is function overload, because you don't have types. You really don't know which function is going to get called if it has the same function parameters. Whereas in NIM, you have a function overload, which kind of overcomes some of the object-orientedness of Python, so you can do polymorphism using function overload. Distribution, I think this is where I really find NIM to shine, is the distribution. When it comes to Python, say if you build a Python library, how do you distribute? How does your users get the library? You have to ensure that the clients have CPython installed. You need to worry about virtual environment. You need to worry about path and all these things. Whereas NIM, you just have a compiled binary and you ship it. Multi-threaded, as we all know, there is GIL. Within a single interpreter, you cannot have multiple threads running, whereas NIM has a true support for multi-threaded functions. Performance, this is a very controversial and subjective topic. Performance of Python depends on what you're doing. I won't say like Python is slow or fast. It really depends on what you're trying to do. If you do IO bound things, you can live with async IO and it's quite good enough. But there are times where when you want to truly utilize your CPU power. At that time, we have seen, and it's pretty obvious that compiled languages are way faster than Python. So performance of NIM is literally comparable to C, C++. And there has been numerous people who have have done a benchmarking, and that's really incredible. So the key difference is type system. NIM is a statically typed language, so you need to be really careful with how you structure your data and how the relationships that are formed. There is less emphasis on object-oriented programming. So this was one of the hardest thing for me when I was getting into NIM, is if you come from an object-oriented programming where you have multiple inheritance hierarchies, you are typecasting objects from one to another, you need to be a little bit careful how you are designing your program. The third point is also very important. Everything in Python is an object, whereas everything in NIM is of value type. And if you are from C++, you know exactly how if you don't know what that means, you can shoot yourself in foot by doing excessive copying, and it can lead to performance degradation. NIM emphasizes on procedural programming. I know procedural programming sometimes might not come off as like the new and shiny things, but procedural programming is what Go is, what Pascal is, or everything is procedural. By procedural, I mean like the way you structure and compartmentalize your program is through functions and coroutines rather than objects and classes. Strict compile time checking is really, really good in NIM. It makes sure that you don't run into runtime problems. So majority of the issues in our program can be caught during compile time. The execution model of NIM, as I said, is very different because it compiles to C and then uses the entire C toolchain to run your program. By taking the advantage of C, it's basically utilizing all the research that we have put into for last 40 years in C, C++, all the compiler optimization, all the memory checks, everything we basically are reusing and using it to our advantage. Okay, enough of talking. Let's just compare those two languages side by side when it comes to code. Oh boy. See. How will I show the code? Sorry. Do you know how? No, it's just like it's showing my browser. That's the problem. What? No. Oh, so I cannot screen anything else? Damn. Well, that's fine. Okay, we can skip this for now, and then maybe, let me see this. Okay. But this was not something that I wanted to show, but I'll show it anyways. So there is this, okay, that's fine. Let me, okay, sorry, I'll show code examples later. Let's just move forward. Okay. This is training room 3. Okay. So I have some code examples in the slides, so we can just go over that. I had my code on my Mac, but unfortunately I cannot stream it. So let's just go over why we should invest time learning NIM. There are many reasons, as I said, but there are these 4 things that I feel is something that drew me towards NIM. It's very expressive like Python. It has a lot of metaprogramming capabilities. So if you're coming from Lisp, you will really appreciate how you can introduce certain constructs that expands during runtime, and you can avoid a lot of boilerplate code that you have to typically write in a statically typed language, example, Go or Java. It's very efficient. As I said, it compiles to C, so performance is not a problem, and it's cross-platform. One disadvantage of compiling it to binary is that it's always system dependent. So if you're compiling your source code on Linux, you cannot run it on Mac and vice versa. But NIM provides you with a lot of tools that will help you do cross-platform compilation, and it helps distribution very easy. Expressive. So I would have given you a lot more examples of how NIM looks like, but this is a very simple example of binary search written in NIM. As you can see, it's readable. Like, even if I tell you to read this code, you will be like, this looks like Python. And if you use Python 3's type annotation, you will see that it looks even more similar to Python. In NIM, you have procedures which are similar to functions in Python. You have your function parameters, and each parameter has to be typed. So over here, I'm just declaring A to be of type sequence, which is a list in Python. The key that I'm providing is of type integer, and the return type of this thing is Boolean. And as you can see, there is like this white space indentation. There is our favorite colons are there. It's very, it uses very minimalistic noise. So it gets out of your way just like Python. So you can just focus on the problem that you're trying to solve without always fighting too much with how the language is and how too many keywords and things like that. So at a surface level, NIM code is very similar to Python. But semantically, NIM is very much closer to C++ than Python. So for example, when you say var low is equal to 0, you're declaring a value type. It's not like how in Python you have like references that are pointing towards a memory where the actual data type lives. This is you're literally laying out in memory. That's why it's a value type. But on a surface level, do you all agree it looks very similar to Python? So NIM has this amazing feature called as universal function call syntax. And this is very new to Python developers, but if you are doing D or Rust, and even C++ now is talking about having this feature. So what this feature lets you do is it lets you call functions using the syntax of a method, so that the first parameter in your function is the type, and the remaining arguments is the remaining parameters to the function. So for example, you have a function called a square, and you want to perform a square of A and B. So you can either do square A and B, or you can do A dot square B. So it lets you write code in more expressive way. And this is not just a syntactic sugar, it also lets you do more polymorphism as we will go deeper into the NIM code. So how many times we have done this? We always do this, where you have a nested function calls, where you first call bar and then you pass the results of bar into foo. So now you can just do a.bar.foo. Again, like if you have like a really chained function calls, it's very, very expressive to write it in more chain manner. And you can go even more further by making it even more readable by using our favorite map filter and reduce functions. As I said, it has a very intuitive, minimalistic type system. If you want to create like a heterogeneous container for your data types, you can just define a type person, which you can say it's of type object, and that type has two fields, name and age. And then you can define a procedure, speak. You can pass the person object, which is the first parameter to this function, and then you can just, then you instantiate a person object, and then you can just call speak on it. Very easy, very intuitive, very minimalistic. This type system lets you express what you want to do in very clear terms. So it acts like a documentation. It ensures that you perform operations that you are supposed to do. Question? Sorry, so yeah, so that's a good observation. So p.name, so name is of type string, and this dollar symbol is basically stringifying the integer to a string. So it's basically p.age.toString. Yes, so I was going to say all this thing in the code example, but the way, I think I'm going to explain this later, the way the module system works is two ways. You can do import.stringutils, and it will import all the exported variables into the namespace, or you can explicitly define from string utils import dollar. So it depends on what you like. I know this has been a little bit controversial subject when it comes to how importing should work, because it could lead to name collision. But with IDEs and compile time check, it lets you avoid most of the mistakes that you will end up hitting during the runtime. But that's a good observation. NIM, like Python, has operator overloading. So operators in NIM are nothing but function calls. So you can change the operation that you can perform on that operator based on the arguments you pass to it. So say you have a tuple called as point, and you want to perform addition of those point. So you just define a procedure with backtick as plus, because now you're overriding the inbuilt plus operator, and then you define two tuples, and then over here you are just basically calling that operator. It's very expressive, and this thing is really important if you're writing scientific and numerical libraries, because you can express more mathematical relationships in very intuitive and expressive way. And this, as you can see, is basically essentially calling the procedure. You can also invent your new operators if you want. If you don't like how range operator works, you can define like, hey, I want to define a new range operator, which is an arrow key, and then you can invoke it in your for loop, just like saying like, hey, invoke this for 0 to 5, and then you just print it. So NIM has support for first-class functions and closures. You can define a function, and you can assign that function to a variable. You can pass that variable to other functions, and you can then invoke some other functions. So this is something we are very used to as Python developers, having this first-class function ability. You can also have multi-line anonymous procedures, which in Python we cannot have because lambdas in Python are single expressions. So there is no longer this limitation with anonymous functions in NIM. I'm going to skip this. So the NIM has a very rich standard library. If you are worried, if you are used to doing things in Python, if your favorite library or if your favorite functionality is not there, NIM's standard library is designed to be very compatible and look alike like Python. So it has JSON, it has async HTTP, it has sync, it has unit tests, it has all the string utils you want, it has all the functions you need to mutate, like list and arrays and tuples. It has dictionaries, which in NIM is known as hash tables. It has a lot of algorithms and all the math functionalities that you are used to in Python. In fact, there is like a couple of people in the NIM community has done one-by-one comparison between every single method in the standard library for string utils, and it matches equivalently. So the standard library in NIM is very exhaustive, so you don't have to worry about volunteer-driven library creation. Metaprogramming. So metaprogramming in NIM is very unique and it's very interesting. If people who are a little bit new to metaprogramming, what that means is like in metaprogramming, you can treat your program as data. So you can pass that data to other programs to modify, create, mutate itself. So basically, programs can modify itself during runtime. And if you have done Lisp in past, this is very natural to you. So how you can do metaprogramming in NIM, there are three basic ways. One is generics. As I said, because NIM is a statically typed language, it enforces you to make sure that the functions that you can invoke takes the right kind of types. To overcome this, you can write your functions in more generic way so that you can reuse that same solution over different types. So so basically in generics, you can invoke algorithms on type whose types you don't know until the algorithm is actually invoked. So for example, you have a max function and you want to make sure that if two numbers are same, or if two floats are same, or if two strings are same. In Python, you can just invoke it and you pass, and you don't have to really worry about it. This is where I said like the duck typing comes into picture. But because of the stricter notion of types, we have to make sure that the type equivalence is maintained. So you define a max with generic type as t, and then you can invoke it for floats and for integers. So as you can see over here on the last line, you cannot mismatch. You cannot just compare a number to a string because it's a type mismatch. So it enforces you to make sure that you understand the relationships of your own data structures and how you are using it. You can also enforce more stricter control over what kind of types you can pass in. So if you want to restrict your function to only use ints and floats, so suddenly you cannot say like, hey, give me the max of 2 strings. It will give you a type mismatch. You can also enforce generics in the actual types. So you can create a node type which can be instantiated for number and for string. So basically you can create containers that are itself generic. Templates. So templates in NIM are a substitution mechanism that works on NIM's abstract syntax tree. So what this means is like you write NIM code, and NIM compiler will take your code and construct an abstract syntax tree, and which the AST is then fed into a compiler, which then converts into C, and then it uses the C toolchain. This is one of the simplest way where you can substitute your code and reduce runtime overhead, because whenever you call a function and you call a procedure, compiler has to go through multiple steps to execute your function. Whereas over here, you are basically going to inline your declaration into the function call. So if you're doing C++, there's an inline functionality that you can use. So for example, I have a template called as multiply. It takes 2 parameters and it just computes a multiplication. So when you call that template using echo multiply 2, 3, what compiler is going to do is going to rewrite it to echo 2 into 3. So there is no overhead. So this is where your code literally gets substituted at the call site, reducing all the overheads you want. It also provides you with macros, and macros are the ultimate way of modifying your code during runtime. And it's one of the best ways to reduce boilerplate, and also you can create like domain-specific constructs in your code. And macros are procedural, whereas I think I forgot to say, templates are declarative. By declarative, I mean like you declare what needs to be substituted and it just substitutes it. Whereas macros are procedural. That means that if you are defining a macros, you also need to write how you want to produce code. This might be a little bit advanced or a little bit confusing, but it's very simple once you understand how NIM's abstract syntax tree structure looks like. What I'm trying to do is I'm trying to multiply the same thing 2 into 4, but instead of writing the code, I'm producing what the code should do at runtime, at compile time. So what I'm going to do is I'm going to pass X and Y. I'm going to just write some code to produce the actual code of my function. So NIM is very efficient. As I said, it compiles to C, and then it takes advantages of C's runtime compiler and all the features that it provides. It also provides you with compile time function evaluation. So what this means is there are certain times where you know exactly what your function should do, so why wait till the runtime? You can actually execute it at compile time, and that will make your code even more efficient. This is something very new. I think the only other language that this has is D. So it's a very new feature that can improve your performance of your program really, really well. It also lets you create really compact binaries. So one of the issues that we see when it comes to static binaries is you put all the dependencies in your binary, so when you ship it, you don't need to have any runtime availability at your clients. But that can lead to some really bloated binaries. So NIM has lots of capabilities that will make sure that you can tweak your size so that you ship the most optimal binary to the clients. As I said, it has a control garbage collector. You can control how long it should run. You can pause the garbage collector when you don't need it. You can choose between different garbage collectors that are out there, built by open source volunteers in C world. You can completely disable it if you want to. I'm not going to go too much into parallelism, but NIM provides you with a really unique structure for threads. So at a very high level, GC safety is very important for NIM. And as you know, when you are dealing with multi-threads, race conditions and memory sharing becomes very, very tricky. So at a very high level, what NIM does is NIM provides an isolated heap for each thread. So when you spawn off a thread, each thread gets its own garbage collector and its own heap. So the memory sharing is very restricted. But you can still pass data types between different threads, but you can use channels for that, just like Go. I was going to go into this, but I think I'm running out of time. Cross-platform. So another really amazing feature of NIM is that, as I said, NIM's code gets first compiled into abstract syntax tree, and there are multiple backends. So you can compile NIM into JavaScript, you can compile NIM into C++, or you can compile it to Objective-C. And C and JavaScript are the two most canonical way of compiling NIM programs. You can also distribute, if you don't want to cross-compile, you can distribute NIM source code to your clients and then let the client build the binary based on what machine they are on. So it gives you incredible amount of freedom with how you want to distribute your code. Unlike Python, where we have to constantly make sure that the users of our library has the right Python version, Python path, and things like that installed. Some of the other language features, so NIM is self-hosted. That means that NIM compiler is written in NIM. Unlike Python, where CPython is C, sometimes that could be a barrier for people to contribute towards Python, but whereas NIM, everything is in NIM, so it's very easy to reason what's happening behind the scene if you want to jump into and debug some at the compiler level. There is no GIL. There is an amazing foreign function interface. That means that NIM can easily wrap any C library that's out there. Because it compiles to C, it can reuse any library that has ever been written in C. So if you ever come across a case where NIM doesn't have that, you can always find a C code that does that, so you can implement that in NIM. It has async await, the thing that we all love. It has default function parameters. It has variable length argument. You can invoke function using name function arguments. There's multiple return types via tuple, just like Python. Case and if statements are expressions, which are really useful. There's a package manager, just like pip. It also comes with a doc generator, so you don't have to worry about spings or how you will generate documentation, things like that. So now that we talked about like NIM is pretty cool, of course, there are some things that NIM is not good at. NIM is still immature compared to Python. It's been around for 9 years, and it's developed by a very small group of people. So occasionally you might run into some bugs, but the good thing with that is that the community is very proactive, and it will fix it as soon as you notify them on GitHub. It has a smaller ecosystem than Python. This could be something that is interesting to talk about, like how much ecosystem is important for somebody to adopt a language. But compared to Python, NIM community is very small. So this is like a big list of projects that has been developed using NIM. And if you are thinking like, where will I use NIM? What should I build using NIM? These projects will give you a lot of inspiration because NIM, like Python, is very flexible. You can write command line tools, you can write web applications, you can write microservices, you can write compilers and things like that. So like, for example, Jester is a web framework very similar to Sinatra. Carax is like a web framework very similar to React. It's actually built by the guy who wrote NIM. So he's building like a single page application like React in NIM. This is like this amazing Facebook JavaScript game that people have developed using NIM. This is NIMLocks. This is like an interpreter to a toy language called as Locks. And this is something I'm building on for me to understand more about compilers and how programming languages work. So NIM is very flexible. Because of the good things that it has taken from Python. It's fun to use. It has lightweight syntax, so people onboarding is very easy. But because of its static capabilities and its execution speed, it can be used for writing really fast scientific libraries like RAMancer, which is similar to TensorFlow, things like that. So it's very fun. If you're looking for inspiration, what I should do with NIM, this is a great list to begin with. And this is like a big list of things you should do, how to get started. There's like a Slack channel, there is like, not Slack channel, there's an IRC, there's like amazing tutorials, things like that. So in summary, the goals of the language is as fast as C, as expressive as Python, and as extensible as Lisp. So the key takeaways is that it's incredibly fast and extensible. It has Pythonic syntax. It's fun to use, it's very expressive, it's minimalistic, it gets out of your way so that you can focus on your actual problem. It produces zero dependency binary, so shipping is incredibly easy, and it has a comprehensive standard library. So it follows Python's philosophy of batteries included. So I hope this spiked a little bit of your interest of what NIM is, and if you're curious to learn a language which is so similar to Python, but yet has some new capabilities, then I would encourage you to give NIM a try, because NIM and Python, they can coexist, and they should coexist because NIM's design is always influenced by Python. Thank you. I don't know if I have time, but I don't know how long I should be talking. I think 2:40, right? Yeah, okay. If you have any questions, I can take some questions.
About the machine learning side of things, how is the community in NIM developing machine learning applications? Are they machine learning applications already built in NIM? or the intentions to build one? And what could be the limitations from the language perspective in machine learning, besides the lack of frameworks or something like that?
I think from language perspective, there is no shortcoming because it compiles to C, C++. And if you can see all the major machine learning libraries like TensorFlow, Torch, and these are basically written in C, C++. So you can reuse the native code in NIM. So it's just, again, the problem with NIM is the small developer community. So it's like a chicken and egg problem. All you need to do is start building more libraries and applications so that you can attract more people. From language perspective, I don't see any shortcomings, to be honest. Yes, so the example that I gave you, Arim Ansar, there's this amazing guy based in Paris. He's a data scientist, and he's building a lot of machine learning applications using NIM. Mm-hmm. Yeah, so the PyMod is interesting. It's basically a bridge between, so you can call Python code, you can call NIM code from Python. But the easier way to do that is basically just write NIM and produce C code, and then just call it from Python using as if you're calling any C code. So there are many options that people have built, and it's very easy. As long as you can use C, you can use NIM basically. Sorry? Yeah. Yeah. More questions? Oh, thank you. I know Julia. I've not played with it. I know it is built. The only difference I see is like Julia is meant to solve a very specific problem in scientific community. So it has a lot of constructs and notions that might not be comfortable for wider developers. Whereas NIM's syntax gives it a freedom to be used not just in machine learning, it could be used for web development and things like that. Whereas Julia's core developer is focused on writing really, really amazing language for data scientists. But the difference is, again, syntax, execution, just a different approach towards it. Yeah. Sorry. Okay. Sorry. I think I ran out of time. So thanks.
Thank you.